Table below gives the electron configuration of 3 elements. There they are. What is represented? 3 means shell or electron level number 3. P means the p subshell. 6 means there are 6 electrons in that 3p subshell. Arrange the 3 elements in terms of decreasing first ionization energy. So from greatest first ionization energy to the least. Neon and then argon, and then the lowest will be phosphorus. First definition, ionization energy required to remove the least tightly held electron from 1 mole of gaseous atoms. Argon and phosphorus have 3 shells, which is more than neon with 2, so argon and phosphorus have more shielding than Ne, and a definition of shielding. Argon with 18 has more protons than phosphorus with 15. So the lowest amount of shielding means that Ne has the greatest attraction of positive protons for negative valence electrons, pointing out that the protons are positive and the valence electrons are negative. Lower shielding is more important than the higher number of protons. So we spoke first about that SPA, so shells and shielding, and then protons, and then talk about attraction. Argon and phosphorus have the same number of shells, 3, but argon has more protons. So the attraction of protons for electrons is greater for argon than phosphorus, and I've already given them my order. The 2 possible shapes of bromine trichloride are T-shaped, this one here, and trigonal planar, this one here. Both of these shapes are based on the trigonal bipyramid arrangement of electrons, blah, blah, blah. BrCl3 is polar. Compare the 2 possible shapes to identify which shape would result in the BrCl3 molecule being polar. BrCl3 bonds are polar due to chlorine being more electronegative than bromine. In a T-shape, the polar bonds are arranged asymmetrically, so the effects of the, dipole, of the bond dipoles of the polar bonds are not cancelled, so T-shape is polar. In a trigonal planar, the polar bonds are arranged symmetrically. They're obviously still the same bromine-chlorine bonds, but now they're arranged symmetrically. So the effects of the bond dipoles of the polar bonds are cancelled, so the T-shape is non-polar.